Hey everyone, it's Nick with RadView Detection. Today we're going to be covering how to do basic gamma spectroscopy with your RadView MK1 or MK2. This will work better on the MK2. It has a higher resolution than the MK1, but this will still work on the MK1 just fine. Looking at our previous setup, we have a positive and a negative wire, and then we have a digital interrupt pin. We set this up in the previous video, but if you need a quick refresher, the positive and negative pin provide power to the device. The digital interrupt pin tells the microcontroller when a pulse happens. So that's how we originally did our count rate. We're going to add one more wire to our setup. You can use any color you want. I use yellow. It's a good analog value color for me. And from there, we can go to the spectrum pin, which is the very first pin for me. Make sure you're looking at it. It shows a little spectrum as a label. And we're going to go to any analog read pin on our microcontroller. For me, I'm going to use analog pin A0. It's A0 by default in the code. So just make sure that whatever pin you choose, you also write that down in the code. From there, we're going to head over to the computer. So on the computer, once you've opened your sketch, you're going to make sure that your board is correct. So here we have the Arduino Uno. And then we also want to make sure the port is correct. They might be different than mine. Just make sure you guys have the correct values for your board. Next, we just want to click Upload and give it a couple of seconds here. Once it's done uploading, we want to head over to Tools and then Serial Plotter. You can see here, every 2 seconds, the code spits out a gamma spectrum. So this is our current background spectrum being gathered. And real quick, I almost forgot. Down here, where the baud rate is, if you're not seeing anything, make sure you set your baud to 1 million. You can see here we're generating a gamma spectrum. It's pretty noisy right now, but if you let this go for a couple hours, it would be clear. We can speed things up a bit by using one of our sources. So I have a cesium-137 source here. And if we put that next to the spectrometer, you can see an immediate peak starts to form. So here are the main peaks of cesium. We have our 662 keV peak right here. That's the energy level. And then here we have a 37 keV peak as well. So from left to right, so I guess on your x-axis down here, this is energy level. So you can see we don't see much over here on the bottom right of the chart. That's just because there's not any high energy parts of cesium-137. Or for that matter, much of our background either. But over here, we do see some cesium peaks. These other peaks here are fancy physics things that happen with detectors. We won't cover those in this video though. If we want to see what a different spectrum looks like, we can switch this out with europium. So with europium, if we just close the plotter and then open it back up, it will show our changes faster. So here we can start to see our europium spectrum. If you guys have any questions, just head over to the website. You can fill out a contact form or feel free to reserve a detector if you'd like one. We should be getting our beta units sent out sometime in the next week or two. And we plan for a full launch near October, maybe November. I hope everyone's enjoying the setup guides. If there's anything I missed or if you're having troubles, definitely reach out. This has been RadView Nick. Thanks for watching and have a nice day.